Okay, ladies and gentlemen, before we go any further with our discussion of points, lines, and planes, we need to really firmly establish the concept of a Fadoogles. Now, probably haven't heard of a Fadoogles before. That's all right. But we still go back to our basic undefined terms. Let's take a point here. Let's make it A. And over here, we're going to make point B. Now, we already talked about previously between any 2 points is exactly one line. There is no other way to draw a line between A and B that is not this line. You say, yes, I can. If I have a point here and a point here, I could go, woo, and make it all weird. But the answer is no, you can't. Because in Euclidean geometry, there are a few assumptions. In Euclidean geometry, there are a few assumptions. First of all, that all planes are two-dimensional. All lines are straight. Okay, so all planes are two-dimensional. All lines are straight. Now, there are some other assumptions that we're going to have to make, but we'll get to those in just a second. So, if you can't curve this line because all planes are straight, which, by the way, those two go hand in hand, because if the plane is not two-dimensional, then indeed you can have a curved line, because if in non-Euclidean geometry, of course, non-Euclidean means a type of geometry where it is not what Euclid put together. If you have a ball, like a tennis ball, a basketball, etc., a point here on the basketball and a point over here on the basketball are connected by a line, but that line has to go around the difference of the shape. But I could go this way around the distance, or I could go this way, or I could go this way, or in fact, a longer way would be even to go back around and through and come back around the far side. And so one line isn't necessarily true. So you definitely want to stick with Euclidean geometry because there are fewer assumptions you have to make than non-Euclidean. Can you imagine if your geometry was shaped like a horse's saddle? If your geometry is shaped like a horse's saddle, now we have all sorts of problems on trying to find point A that's over here and point B that's on the back side of the saddle. So we have all sorts of non-Euclidean geometry that we're not going to deal with. But let's get back to Fadoogles. Now, one of the concepts of the Fadoogle is based on the betweenness theorem. Okay, based on the betweenness theorem. The betweenness theorem says that between any 2 points, there is another point. Now, let's test this a second. If I have point C and I have point D, and I put them here on the piece of paper, I can clearly say that, yes, indeed, probably there is a point E somewhere between them on that line. But then you say, wait a minute, I have C and I have E. Maybe I could put another point on the line. In fact, I'm going to put it right here. That's a C, E, C, D, E, F. But you say, whoa, wait a minute. I can still jam one in here between C and F. That's G. But then again, I could even put one here in H. But if I use my giant magnifying glass, I could really expand this such that I see C and H, and now I can fit lots more points between them. So the betweenness theorem isn't so much that there is a single point between any 2 points. It's there's at least one point between any 2 points. And by at least, I actually mean there are an infinite number of points between those 2 points. If we could zoom in super duper 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 far, we could really find an infinite number of points between them. But when we zoom out, they may only appear as just to have 1 point. So betweenness means there are an infinite number of points between them. Okay, that is going to be a foundational concept, not just for geometry, but also for other mathematics. Now, let's get back to Fadoogles. Because see, if there are infinite numbers of points between these places, then we can make a unit. Now, an actual international Fadoogle is this length right here. It is right there, the width of my thumbnail. That is a Fadoogle. And so if I were to measure the distance between A and B, I could measure it, and I'm going to call it 1, 2, 3, 4, 5 full Fadoogles. So that would be 5 FA. Although you could get even a bit more specific, you say, well, okay, that looks to be approximately half a Fadoogle. So maybe it's somewhere between 5 and 5.5 Fadoogles. Okay. And so you can use that international measurement as a means of finding length of a particular segment. Now, we could also do this. If I call this right here, this point C, at exactly 2 Fadoogles, what I can say is that this line from A to B is not just 5 Fadoogles, A, B. Now, by the way, it's a segment. You cannot measure the length of a line in Fadoogles. You need to ask yourself why you can't measure a length of a line in Fadoogles and then answer the question. So we have a length of a segment. If the whole thing is 5.5 Fadoogles, A to C looks clearly to be 2 Fadoogles, and that would mean, therefore, that I could find this missing component. And you say, well, duh, do the subtraction. But what you just did by doing the simple subtraction of saying, well, duh, 3.5 Fadoogles, is you actually covered about 1,000 years of math history. Because it's not quite that easy. You see, the whole point is a Fadoogle is a random length. And we just simply agreed that a Fadoogle is that particular length. And by using that particular length, we could physically measure it and I can show it to you. But can you prove to me that that's how much a Fadoogle is? The answer is no, because I totally made up a Fadoogle. They don't exist. On the other hand, if I were to take this, we're all familiar with this, it's a ruler. I could also call this 4 3/4 inches. So 5.5 Fadoogle happens to be approximately 4 3/8 inches. But you say, fine, I could do better. All I have to do is turn the ruler around. And now instead of inches, it is approximately 12 centimeters. So this is also approximately 12 centimeters. So it doesn't matter what your units are. The inch is just arbitrarily defined. By the way, the inch was approximately the width of a thumbnail. That's where the inch came from. Or the distance in one of the knuckles. I can't remember which one it was. I believe it's the index finger. That's where it started because it's an English system. But then we have the metric system. All of these are arbitrary dimensions. But the idea of the betweenness theorem put together with an accepted dimension means that now I can take any length and I can then add that length, subtract that length, I can multiply, I could make something a total of 2 AB units. If I said 2 units AB, that would be approximately 24 centimeters. It would probably approximately 8 3/4 inches, or it would be 11 Fadoogles. So the idea of measurement becomes very important, but it's all based on the betweenness theorem, and that's where we're going to go from there.